All right, sweet. Let's get started. Just do one of these. We can start. We've already done the first one. It's on the notes. So let's grab like this really hard one, like the 1001 one. Holy crap, that seems really hard. Oh, let's do it anyways. So it's just all, it looks like odd numbers, right? If we were to label those, that's like, this is not what this question is asking to do, but just since we can do it now, this is probably like the set of x, where x is an odd number. It wasn't just a bold O. We didn't have any special thing for it. It wasn't like that. No, that's an empty set. So it's just a bold O, if you want to see it when you're typing it on a thing, where x is an odd number, comma, x is less than what? Or equal to. Actually, we could do that. Yeah. Ooh. But also, don't do that. Great. I gotta erase it. X is less than or equal to 1001, but it's greater than or equal to 1, because we don't want those negatives. That has nothing to do with the problem, but that's just kind of roping in what we did the last day into what we've been doing. Just like, oh yeah, we can write these in this way now. So that's just a fun way to write that. But that has nothing to do with adding them up. Here's what has to do with adding them up, which would be you take the first number and the last number. This is the most concise way to do it, I think. Take the first number and the last number plus 3. So what's the next number on the second row? Well, we're only doing odds. 9, 9, 9, just 3 of them, not 4 of them. Is that right? I think so. Okay. And then plus, let's do one more just for safety. 5 and 9, 9, 7. Then we can do a big old dot, 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 and we can skip to the end. 1001 over, well, don't say over, but it is over a 1. So here's kind of a side note for that situation. How many numbers are there? I think it's probably 500. What did you think that? 500 numbers? 501 numbers? 1, 2, 3 is 3 minus 1 is 2. Here's what I always do in my brain just to be safe. If you're taking your test and you don't want to mess up, what's 3 minus 1? 2. So you actually have to add that 1, right? And that gives you your number of numbers. That's kind of how my brain thinks of it. It's like, oh, I can subtract the numbers, but then I better add 1 to it, right? Which is where y'all got that number from. So 1001 minus 1 is 1,000. Add back that 1 because we got to include it. So, but we're only doing the odds, so it's not 1,000 numbers. How many numbers are there in there? 501, I think. And we can make sure. Yes, he said yes for sure. I mean, if you want to count them, you're welcome to count them. And there's 5. So this is, and this is kind of why I'm writing this. This is one set of 501 numbers, right? That's a side note. Side note, so you don't forget, because I'm really tempted. The side note's there because I'm really tempted to write 2. Like for 3 minus 1, 2, there's 2 numbers. Right. But for me, it's tempting to look at this problem and just say, oh, there's 1,000 numbers. 1,001 minus 1. It's just a temptation. So I always think of 1, 2, 3. 3 minus 1 is 2. Oh, that's not right. I have to add. It's 3 numbers total. There are 3 numbers there. This is a second set of 501 numbers. Just a fun little thing for us to remember at the end of this. And if we add these together vertically, we get 1,002, 1,002, 1,002, dot, 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 1,002. So how many 1,002s do we have? We have 501 1,002s. But wait, that was 2 sets. So you know what we got to do? Divided by 2 and you're done. That's not fun. So 501 times 501. Is that cool for me to just do that little division first? The highlight gives you where I got the division from. And then I guess we're going back to the 3rd grade or 4th grade. You remember that? I did include this from the Texas thing. there were only really 3. Like I looked at 2 years of Texas's tests for EC through 6 and for high school, and there were only like 3 or 4 types of questions that popped up on the test. So I'll try to add that at the end of each time so we can kind of think about it as we go. All right. For the Texas is what you have to take to get certified as a teacher. And there were only, from the first 2 chapters, there were like 3 types of problems. Look like that. So those are just like not necessarily out of our book or anything like that, but I just pulled them from the Texas test because they kind of are similar to ours. Like a bag contains 16 coins. How many combos of coins can you pull out? We talked about that with like the ping pong tournament or stuff like that. It's kind of a similar question. This is EC through 6, and there weren't any from the other stuff even though I looked. Because the other stuff is really more like mathy, like physics, math, and stuff. Okay, what else? I don't want to waste any time. But no, those 3 were all EC6. So number 4. Yeah, number 4 is literally just a counting problem. There's no like special way to do it or anything. It's just let's. But it is like a trick question. This was out of section 1 when we said there's just a bunch of random different types. So how many squares are in the figure? Personally, this is my favorite type of question. I know it's not like the most mathy or whatever, but it definitely is like puzzle based. And I guess when you're teaching students, you can teach them to think outside of the box or to read carefully. So how many squares are there? Yes. Thank you for letting me know. Oop, we're connected again. All right, how many squares we got in this figure? Let's make sets. Let's make sets of squares. Oh, did you already count? I haven't done it yet. I don't know. Let's make sets. How many 1x1s are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. How many 2x2s are there? I guess this is the way that my brain would start doing it right away. It's just because like this is the easiest way to do it, right? 1. I should not do that. I should do this. 1, 2, 3, 4. Any more? Okay. And how many 3x3s are there? 1. So total is 18. Good call. I guess that would be, if you look at day 1 at the bottom, which we didn't really go over because we all did videos and stuff, but there were like 8 different ways to solve problems. That type, I guess, would be breaking up a problem into smaller problems, if you were to label it. Not that I'm not asking you to label it, but that's breaking up one big problem into 3 smaller problems. But you, as a math person, teacher, or student, had to figure out what the 3 smaller problems were. They didn't give that to you. You had to say, oh, they could have asked me 1x1s, 2x2s, or 3x3s, but they didn't ask me all squares, so I broke up a big problem into 3 smaller problems. Whereas this is more pattern recognition. All right, what else? We could definitely do a truth table at some point. I'm sure it wouldn't hurt. Or one of these statement type things. Six numbers, letter C. 6C. Definitely looks hard. For each of the following sequences, determine a pattern and draw the next figure. Oh, well, that's not too bad. As long as they don't ask us to make it like a, what's it called, a math formula for it. If they said put a formula to it, it makes it like 10 times harder, and that's probably later on in the year. But if they're just asking us to draw the next thing, they're just saying, hey, can we write kind of in words what the pattern is? And that would fall under that pattern recognition. Again, let's do it up here. So in words, what can the pattern look like? I think 1 extra square, if we write that, right? Add 1 square to the bottom row. And then what do they do? This one had 1 and 1, right? 1 square, 1 triangle. This one had 2 squares and 5. Oh, I lied. Well, technically 5, but 4 triangles. 3 squares and 4, 5, 6, 7, 8, 9. 9 triangles. So that's not a good pattern. They did +3, then +5. Maybe my guess is +7. Let's find out. We definitely know there's going to be an extra square on the bottom, right? Boop, boop, boop. We definitely know they're going to have at least one right there. And then if we follow the second pattern, they added like this diagonal trapezoidal looking shape that had 3 in it, right? Ooh, this is a funner way to do this. Watch this. I've changed my mind. I want to do it a different way brain-wise. Square, square. Second step, extra square, triangle. Oop, but now we got to connect them. Connect, stack. Third square, triangle. Oh, you know what we got to do? We got to make this a tower. That's a better way to do it. So now the fourth one is definitely going to have an extra square, and we just got to finish the pyramid looking thing. Which my guess is 7 triangles, but I don't know for sure until we do it. How many triangles did that add? 1, 2, 3, 4, 5, 6, 7. Plus 7 triangles. Plus 1 square. So that's the new shape, yeah? Everybody cool with that? And if I wanted to put the extra words that we just determined on there, we still added 1 square to the bottom row. But what else? And then we added 2 extra triangles to the shape each time, I guess, if we're being super careful and taking our time. Because we started with 1. No, because the first one we added 3 extra triangles. Oh.
It's like a square.
The number of squares times itself.
The number.
2 times 2 is 4.
Oh.
9.
No, wait.
4 is 16.
Oh, that's the total number of triangles, not the number added. That's another cool way to look at it. Is triangles is number of squares squared?
Yeah.
And I should say not triangles, I should say total triangles, yeah? But we did add, which is also interesting that those 2 patterns relate. So each time we're adding an extra 2 triangles to what we've been adding, right? So the first time we added 1, and the next time we added 3, and the next time we added 5, and the next time we added 7. So that would be an interesting problem. Not one to do, but how adding 2 extra each time relates to squaring. I don't know that I believe that. Especially on the 5th one. Because the 5th one's going to be 25. The 5th one's going to be 25, right? Has to be. So that means that but in the pattern that I came up with says that it should be +9 triangles, right? Because we did +7 last time. So is that going to work? Where's I need another color. Doom, doom, doom. 1. This is just for fun now. +5 squares, or not +5 squares, but 5 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9. +9 triangles. So every time, I really am interested in that. We won't do it because I know we got to move on. But how adding an extra, that seems like it's a consistent adding pattern. 2 extra triangles each time. And squaring, we know, is not adding. Squaring is exponential sometimes. Like it goes through the roof. So this is just a cool shape to like visualize what squaring a number actually does. Pretty freaking interesting. Okay. What else we got? Yeah. Yeah. Underneath it or above it? The 10 and 11 basically?
Yes.
Okay. Yeah, I think we should. I don't think it's bad at all. Let's do the words first. because the words seem to be the harder thing, I think. Maybe not. And then also, if we want to go and grab a truth table from the other packet or the more words from the other packet, we probably can, because I think it'd be a safe bet to know that we can do that. All right. Write each statement in its symbolic form, and they gave us the statements, right? They're using the reigning. They're using the one we don't like. So that's okay. So what are they saying is raining? I'm going to do it colored too. It is raining is P. And in red, the grass is wet is Q. Okay. If it is raining, then the grass is wet. So let's do A. If it is raining, then the grass is wet. Everybody cool with that? And we could probably build a truth table for it if we wanted to. Just to be careful. Not going to, but just letting you know if you're practicing at home, building out a truth table is a good way for you to practice. Making sure that you know what that arrow means. We'll screw it. Here we go. Can't help it. P, Q. P implies Q. How we build out a two-step truth table. True, true. Indeed, indeed, indeed. True, false, true, false. Okay. Now, if-then statements are the worst. We all know that. True to true makes it. True to false makes it. Yep. And that's one of the ones we're just saying, hey, screw it. We got to remember it. A false precedent. Whoa. Ignore the recording. A false precedent makes it true completely. For this arrow thing, this if-then statement or this implication implies is the way to think about it. Okay, so then the next one shouldn't be too crazy. Not rain means
Does it not also have another symbol of half of the square? Right?
oh yeah. If you want to write not the other way, you can. Like that. Yeah, you can write not either of the two ways. You'll get full credit. Not P implies what? Q? Wait a second. What is that? That's false, right?
It's just always right.
Oh, wait, that's not. I know, but we're just thinking in our brain. Can we say that that's false? Why not? Why yes or why no if we're fighting with it? Yeah, what if the sprinkler's are on? Yeah? I guess the other one wouldn't make sense if you have a giant tarp covering all of the grass. Then you know what I'm saying? This false case right here could be destroyed by a giant tarp covering all of the grass. But barring that, this is pretty good example. If it is raining, so if it is P, then not Q. Okay, these types of questions are way easier than what we did in class. These are just can you write it? So, and this is straight out of the book's test bank and stuff. So this is kind of more the speed of things that we're looking at. So hopefully this is a little more comforting than notes in class. The grass is wet if it is, the grass is wet if it is raining. It's the same as the first one, right? P implies Q. They just flipped it around on us.
Why wouldn't Q be first?
Yeah.
Did I mess up?
It's the way they write it. So if you see that if it is, that would go in the front. And
Mm-hmm.
then you just put then after the grass.
Yeah, they're just trying to be mean. Look, because here's the if it is raining is the exact same thing as this statement right here. If it is raining. The grass is wet if it is raining. It's not saying if the grass is wet, it is raining. That would be Q implies P. Ooh, F is a good one. F is the only one that's a little tricky here. The grass is not wet, so that's not P, right? Implies that it is not raining. Wait, did I mess up? Yeah, I did. I did. Yeah. Because the grass is not wet, the grass is wet, right? So not Q implies not P, and that's got a name. Doesn't that have a name?
It's not converse.
It's not the converse. It's not the contrapositive because but it is a flipping both and switching them. Right?
Because E has implies, that's why you switch them, right?
What?
That, like, instead of it being negative P and then negative Q or whatever it is, because it says implies, that's why you put the grass is not wet first.
Yes.
And not for the other.
Yes. Implies kind of means the same thing as if we were to take that exact sentence, this exact sentence, and write if the red line, I'll change the color of that. That means the exact same thing as if the grass ... Then implies means if then. It's the same literal same meaning. Let me think about that one. What you were just saying. Then not rain. And then the grass is wet if and only if it's not raining. It is raining. So that would be the grass is wet is red. Q implies P. And what? P implies Q. But there's a better way to write that. Yep. And you're more than welcome to do that. I just wanted to write both so we could see both of them. Q, double arrow, P. Yeah.
So you can write P, double arrow, Q.
No, you can't. Those two mean the exact same thing. Unlike most of these things, you're absolutely right. These two mean literally the exact same thing, and you both are perfectly exactly the same.
So on a test,
Oh, yeah, absolutely. On a test, yeah. The first thing, the longer way to write it would have been fine. I'm going to write this over here. Same statement. All right, what else we got?
Is there probably like 10 going to be on the test?
Like 10?
Like 3 variables?
Probably. Well, that's because it's on here. And it was on the, yeah. It's not hard. Especially if you're given the table and you're given the setup. It'd be a lot harder if you were only given the far right statement and nothing else. Yeah. No. If we're doing something crazy, you'll get the whole setup. If we're doing like a 2 variable thing, like that thing a second ago, like this one right here. And I said, write the truth table for, I was about to zoom into it, that one. Then maybe I would just say, hey, write the truth table for P implies Q, which is, you can do that. But if it's something crazy like this one, I'll probably make it the right size for you. So here we go. The first 3 you should get. No problem. I got to make this smaller. It's not working. There we go. So P is going to start off as true. And then false. And I'm just going to keep P as green. Q is going to be true, false, true, false. And then R is going to be true, false. Can't do that. True, false. Somebody gave me one. It was laugh. Never mind. All right. So let's see what this is saying. This is saying green implies red. I'm so dumb. Green implies blue. I'm going to, as soon as I see that implies sign, knock out all the false cases first because they're so, I don't want to get tripped up by them later. So I'm going to go down. I'm going to say, where's green false? This whole bottom? True. because that's the most mind-trippy part of it, where it's like, oh, I might mess that up later. If you ever see the imply sign, just go ahead and knock out all the false ones, I think is helpful. Because then now we can think about it. We don't have to think about this anymore. Now we can think. True to true means true. True to true means true. True to false means false. True to false means false. Okay. Now we're going blue to red. Where's those false statements at? There's the blue falses. Every other two. The true, true. True, true. I'm going to highlight these. If you're watching this later, I'm highlighting these. I'm going to add a little orange note at the bottom that says, did these first. And that's the false to true case and the false to false case, right? Same thing here. That makes sense? You don't have to do those first. I think as I learned these, whenever I learned these for the first time, that's what I ended up doing because I just didn't want to mess up that opposite sounding thing. All right, now let's go true to true, true. False to true, false. True to true, true. False. True to false, false. I said it backwards the first time. Whew. A lot of implications. Okay, now we've got green implies red, where we have to skip a step as we read it. That's not fun. So let's go find those green falses. Oh, shoot. They're the same as before, yeah? That's nice. True, 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 true. Highlight them and let you know that's what I did first. Now let's go find these statements. True to true, true. True to false, false. True to true, true. True to false, false. Questions so far? That was the hard part. Your initial thing is the hard part because everything else should just be one thing. Like add ands or whatever's. Do this with a different color highlighter. This will be fun. Blue highlighter. Where do you see this blue highlighted P implies Q? Probably right there. And where do you see this orange highlighted, purple highlighted, Q implies R? Oh, you can't see that very well at all. Sorry. You can on here. When you watch it, if you go home and you watch it because you're studying, it looks great on here. on the projector screen, not so great. Q implies R. Okay. So blue, ooh, and this word means and, right? What is that? That's a conjunction. And the other one, the or, is a disjunction. Okay. The and means they both have to be true, right? All right, so we're looking at those two columns that we just highlighted. True, true, true. I'm just going to go look for any other true truths because that's so rare. Down at the bottom. Any others? Right there. Any others? Nope. So, false, false, false. If I mess up, yell at me so we can fix it. But I think that's good right there. Oh, see? Yep, you're right. I knew it. Wait. That's okay. True, true, true. True, false, 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 true. You were looking at the side by sides right here? Yeah, I could highlight the whole column, but that would look really messy on here. It would look fine up there because it's not that dark. They're way darker on this screen. See? Like very dark highlights. Is this our last one? Oh, I can't shrink it. I've written so much. I need somebody to look at the thing. Is that the last column? Okay, good. It's a little off the page. That's okay. All right, so now we're saying the new column we just did, which I will make a red highlight. You'll be able to see that. This red highlight. Can you see it? Okay. Oh, wow, yeah. That red highlight is the first thing, right? And we're saying, where does the red highlight imply? There's a black highlighter? Yeah, there is. Look at that. That's crazy. The black highlighter. So this is going backwards, so we got to be really careful. So where does red imply black? All right, I'm going to do that thing where I go and check for the falses first so I don't mess them up. So where is red false? True, 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 true. Those are the one. These highlighted ones are the ones that I did first for that same reason, because I just didn't want to mess anything up. And then we've got a true, true is a true. We've got a true, true is a true. We've got a true, true is a true. Holy crap, it's almost like it's an identity that's the transitive property. If I live in, this is the same one, I think we've done something similar. If I live in Houston, I live in Texas. If I live in Texas, I live in the United States. Therefore, if I live in Houston, I live in the United States. So that's a good way to think about that one if you want to, where P is, I live in Houston, Texas. Well, that's dumb. P is, I live in Houston. Q is, I live in Texas. And R was, I live in the USA. And you would just think it out from there. And that would be a good way to think that out. Awesome. A lot of time on that one, but that's okay. What else we got going on? Back up top. $15? Does everybody feel okay with 15 or? 15 looks the messiest to me, but we don't have to. I'm just looking through hard ones. Five? There is no 5. I skipped the number 5. Look at 12. Converse, inverse, contrapositive. Love it. All right, hit me up before while I'm copying and pasting. What are the definitions of each of those? The converse is the one that you would think, like the one that you would think they would teach first, right?
Is that the one that's like the complete opposite?
Where that you just change one thing. Go away. Go away. Are you kidding me? Go away and stay away. All right. We got converse. Inverse. Wasn't there one more? No, when we learned them originally. What was that in the same definition part of the thing? I thought there was like one, because I remember doing 4 things at once. There were 4 definitions back to back to back, and then I'll also make sure that we nail down the definitions perfect. So this would have been in 1.1 or 1.2. What do you think? Oh, 1 was just the fun. Yeah, 2.1. Dang. I really do think there were 4 definitions, but I could be crazy. There were 4. Oh, I'm dumb. Okay. The one of the 4, it's so far behind me. One of the 4 was just the state. Yeah. So. So these are our statements if you want the 4th thing. You know what I mean. For each of the following implications, or you could call them statements. State the converse, the inverse, the contrapositive. All right, so the converse, what's a good way to remember that in terms of like easy words? Yeah, like flipping them. Like, I'm just trying to think.
Only one. So you say that, I kind of think both sometimes, like the whole statements. But
Like this. It's not. No, I'm just trying to think of like a way to remember it in your brain if we're trying to like make an acronym or something. Well, here, we can write it and then we can think of it. If x squared equals 9, then x equals 3. And then the inverse is not, right? Which is if it snows. Is it flipping the first one or the second one? Oh, it flips both of them. Thank you. If it doesn't snow, then classes, which isn't necessarily true, aren't canceled. And then contrapositive is the one that is necessarily true. It says if. Oh, wait. I've totally shot myself in the foot here. If classes are canceled, not canceled. I'll go back and fix the first one. If classes are not canceled, it is not snowing. That is necessarily true. I didn't realize what I'd done. If classes are I guess like left and right, Converse or shoes. This is what I would do if I were teaching a class. Converse or shoes. Shoes have a left and a right. Switch them. No knots, no buts, no ands. Shoes have a left and a right side. Just switch them. That's Converse. If classes are canceled, then it is snowing. Inverse a little bit harder, but inverse starts with the sound that's in, and that means not. So just not in both. And then contrapositive is the worst one. Just not flip. Flip everything. Flip the true statements, flip the order, flip it all. So that was the contrapositive earlier then. I was a little hesitant to say it was exactly that. But where it's not, and flip, I think we did one earlier. I'll go check and make sure. I'm not crazy. What example was it? This one? 11E. Not. So the not, and reverse order. Oh, I guess we need a statement first for it to be the contrapositive of. But we could say that's the contrapositive of A. But you'd have to have, that's why it wasn't perfect, like to say, this is always a contrapositive. That was just the contrapositive of A. So converse are like shoes, left and right. You just flip left and right. Inverse starts with a sound that's in. That in stands for not. Contrapositive sucks. That's how I would remember them. Contrapositives, not, and switch them. Do both of them at the same time for everything. So, contrapositive. But the positive is probably there because somebody at some point realized, oh, if we do this thing, it's always true. It's a tautology. And so they called it positive. That's where the positive part of it comes from, is that this necessarily is the exact same statement as, if it is snowing, then classes are canceled. Okay. Heck yeah. Oh, this is one of my favorite types of questions. I actually really enjoy this question a lot. Okay. We got baseball. And this one's actually just one step harder than the one we did in class, only because they each play them twice instead of once. Once was a little bit easier. Twice is going to make it somewhat tougher. Okay. Cool. Okay, I have to go buy something. I need to go buy a VGA to HDMI adapter, I guess. Because I have an HDMI to USB-C. This is the worst. Whenever they made ports smaller, everything got worse. Every computer used to, I like it, but it definitely is causing issues. Okay. Baseball League has 10 teams, and they each play the other teams exactly twice. You can assume they mean exactly, not just at least. How many games will be played total? So let's just take it one team at a time. This is how I end up doing it in the notes. One team at a time. Here's team one. Let's call them green team. Team one. And we'll end up doing more than, actually, no, I'm going to do it this way. Team one. Okay. How many games does team one need to play? They need to play team two, right? And team three. And team four. And 5, and 6, and 7, and 8, and 9, and 10. Right? Team 1 needs to play all of them. But you know what else they need to do? They have to play them again, right? Team 2, Team 3, Team 4, Team 5, Team 6, Team 7, Team 8, Team 9, Team 10. And we're not going to end up having to write these for every single one. It's just a way to visualize it. So how many games is that?
9 games. 18.
9 times 2. Right, 18. Nine different teams to play. 18 games if you're doing them twice. Okay, now let's hop over to Team Blue. And by that I mean Team 2. How many games does Team 2 have to play? 3, 4, 5, 6, 7, 8, 9, 10. Do we need to write 1 in there? Why not? Because right there they've already played 1 twice, right? They've been taken care of. So we'll do it again. 3, 4, 5, 6, 7, 8, 9, 10. And how many games do they play? And I think we got our pattern. Let's do a third one just to be careful. We won't do 10. We'll do 3. But I think we've got our pattern. Red team. Team 3. How many games do they need to play? 4, 5, 6. And how many games is that? I think we could guess without even counting. It's okay. 14? Okay, so we've got our pattern. And you know what this problem just turned into? The problem we did at the very beginning of the day. Because what's 18 plus 1? What's 16 plus 2? What's 14 plus 3? Oh, shoot. See what's about to happen here? How many total games do we need to add up? 19 plus 18 plus 17 plus dot, 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 plus dot, 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 plus dot, 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 and let's work our way all the way down. You want to start with 9 or 10? We could do. You could start either place to finish this off. What do you want to do? 9 or 10? So that you can have a little safety net of like, wait, what if I mess up the last one? I do too. That's how I always do it. But if you're confident in yourself, you don't have to. Team 9. How many teams do they have left to play? Just Team 10, and that's 2 games, right? 9 plus 2 is
11.
Okay. Team 10. How many games do they have left to play? None. They've done their thing, right? So there's a 0 number right here, right? Which we don't have to include, but it's just, okay, we're done. 2 was our good number. Okay. So what numbers are we adding up then? We've got like 6 different rows of numbers, and our job is to figure out what number we're adding up.
So would you add 19 plus 18 plus 17 down to 11?
That was... Why? Talk to me about why. Oh, okay. I should have done this then, and that might have helped you. That was for a pattern recognition type thing, which is totally fine. But I was just trying to recognize a pattern of dropping 1 every time until we got to the last thing. So that is probably my fault that I didn't draw that column. But total games is actually the left thing, right? Plus 16, plus 14, plus whatever, all the way to 2. And now this turns into the first type of problem we did. Or if you're just going to manhandle it, you can manhandle it to make sure you're right. Or you can do both. Because this one, only because this is one that seems like you could manhandle it. It's going to be 10 addition problems, right? You could take it to town if you wanted to. Or you could say, what's 8? Actually, I'm going to start at the low side. 2 plus 4 plus dot, 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 all the way to 18. And then you know what we're supposed to do after that? 18 plus 16 plus dot, 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 all the way to 2. And they all add up to 20. How many instances are there? Or how many 20s do we have? 9? They're odd. Or even. We skipped 1 every time. I think there's only 9, right? Because that was our team number right there. See the team number on the left? 1 time, 2 times, 3 times, 9 times. The 10 doesn't matter because there's 0 total games played in that column. So there's nine total sets of 20, right? Okay. 9 total sets of 20 means we do 9 times 20, which is 180, divided by 2, which is 90 games. 90 games gets everybody to play everybody else. If you hate that, you know what you can do? 18 plus 16, get the answer. Plus 14, get the answer. Plus 12, get the answer. Work your way down. Hopefully you end up there. If not, one of us did something wrong. I would bet on me. But cool.
How would you write the rule for 8?
The rule?
For number 8.
Oh, for 8, sorry. I was looking for the rule for that, and I was like, oh, I don't know. Write a rule that uses... Interesting. Did you come up with one and you just don't know how to write it?
Well, like, I know the pattern, but I don't know how to write it.
What's the pattern?
Plus 5 times 2.
Then that's exactly what you're right. This is probably from section 1, so it's like before we did any formulas or any numbers or anything. So you're saying that it's, if we're looking at it, it is plus 5 minus 2, plus 5 minus 2, plus 5 minus 2, right? So that means we should have 15, 13, and then write the rule. Maybe you qualify beginning with the number 1, just so we know where to start. Beginning with the number 1, add 5, write the sum, subtract 2, write the difference. Just so nobody's tempted to do it all in the same step. It would be the only thing I would say is important to notice. If you were just to say add 5, subtract 2, and you're talking to like a kid or to me, they might be tempted to do it all in one step. So you just like say, okay, hey, make sure you add 5, write it down. Subtract 2, write it down. Repeat as many times as you're told to. In this case, 6 times, but who knows? Okay. What else we got? Sure. It's not going to be fun, though. I think the best way to do 16 is to identify the thing by starting with 1, 2, and 3. I was thinking about this because this is pretty much the homework, but with way more, which is still due maybe on Monday, whenever you can get it in. I don't mind. Pretty much just the homework, but with way more, right? So watch this. I was thinking like, okay, what would have been a better way to explore? Because that explore thing, the second question that we kind of skipped, said, how could you figure out what the pattern is? So here's a good way to kind of think about the pattern. The first way is you can just look at the book because it tells you what the rule is. But if you don't want to do that, then a really fun way is think about what if it was the set of 1. How many subsets does the set with 1 element have? It just has 1, right? The set of 1. Excluding the empty set, which I think we do. What about the set of 2? How many, whoops, that's not what I meant, right? The set with 2 elements has how many subsets? Subsets, not proper. Yeah, subsets, not proper subsets. 3. 1, 2, and 1, 2. 1, 2,
Oh, yeah.
and 1, 2. Now, proper, if you think about the British definition of the word proper, meaning like better or proper English, like better English, the better subset is what we would imagine subset means, which is what it like actually has less numbers in it. Proper subsets. Okay, so we got 1 means 1. 2 means 3. What about 3? We're going to have 1, 2, 3. We're going to have 1, 2. We're going to have 1, 3. And we're going to have 1, 2, and 3. All right? 1, 2, 3, 4, 5, 6. So we got 6. Interesting. Okay. Anybody see a pattern yet? Not one that's easy. 1, 2, 3, 4. Because with this one, I don't think there's any chance we're listing them all out. We're just going to have to use the formula, right? So the better thing is to explore and find the formula. 4 is going to have how many? Did we do this one in class already? I think we did. We did 1, 2, 3, 4 right before it as well with A, B, C, D. Was it 16? Did we mess up the other one? The 1, 2, 3 thing. 1, 2, 3. Oh, we missed one. I missed one. I say we. Is it 2, 3? It is. 1, 2, 3, 4, 5, 6, 7. Whew, scary. Okay. Make sure we didn't miss any more because I do that often. So what was the 4th thing? If you look back at the ABCD notes, I can pull them as well. Just so we don't have to list them all out all over again. Somebody beat me to it, though. Somebody beat me to it. There it is. Where is it? Oh, did we do it? I could have swore we did A, B, C, D. Oh, not subsets?
Yeah.
So this is the only thing we've done with subsets so far? Ah, rats. So we did do 5, though.
Yeah.
Did anybody get it for homework? You got 30? Did you get 30? Don't look at my notes then. I counted bad. Oh, I definitely counted bad. I listed them all. Anybody? Y'all see the red circles? Hang on. That's so bad of me. Okay, 10 plus 10 plus 5 plus 5 is not 20. Just so you know. It's definitely 30. Those are the right things, but so 5 turns into 30. 1, 2, 3, 4, 5. Oh, crap. 30. Anybody see a pattern yet? To be honest, I'm not seeing a good pattern. This is why this was on the Explore section. All right. When all else fails, let's go find out. Somebody do research. Somebody type in the good question and try to beat me to it. What's the good question? What would the question be?
Is this just subsets or proper subsets?
We are doing subsets first, but then we'll do proper. But somebody do the good question. Somebody subsets based on cardinality, I guess would be the good question, right? Formula for subsets based on cardinality. And we'll see if it applies to the numbers we found. And I'm guessing 4 is somewhere in between 7 and 30. Go to Google. Hurry. I'm going to try to beat you, though. Numeration. Go, 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 go. Do I have the formula memorized? No. Should you? No. We didn't do it in class. And it was the last thing we even did. Anybody find it? Subsets based on cardinality. Number of subsets in a finite set. Boom, there's all the stuff we did. Looking pretty good. Looking pretty good. 5 elements. Right of what? you find it?
It's a bunch of letters.
Is it a crazy long formula?
It has like natural logarithm and stuff.
No way. Does it actually?
Yeah.
No, I'm looking at it right now. 2 to the n. The number of elements, look right here. Number of elements, number of subsets. If 1, then there's 2. If 2, then there's 4. If 3, then there's 8. So we're missing 1 each time. What is that 1? And this saves us all. We're missing, so based on what we just wrote, and this is really good learning for me and for you, we're missing 1 each time to make a good pattern. Which one are we missing?
Can you do like the reverse and do 2, 1?
No. Indeed.
Oh, so
Boom.
you do it.
Boom. We do. Boom. Boom. Okay, so now what they're saying is, is there a pattern with 2, 4, 8? Did we mess up the 5? 31 seems not good. I might have to do the 5 again. You're the one.
Empty sets for all of those, right?
Yeah. I'm just saying, the pattern looks great until...
Why do we have to add an empty set?
It's 32?
Well, that's what 2 is.
Yeah.
Oh.
So we're missing 1.
Oh, I know what the 1 is. That was a different problem. They asked us a different problem, didn't they? On the notes that day, they asked us for propers, not for regulars. So what subset on the notes are we missing? Not,
1, 2, 3.
yep. So for the 5er, we were missing the empty set and the 1, 2, 3, 4, 5 set, and that gets us to our 32, which is 2 to the 5th. Aha.
Regular subset.
Yes. Proper, by golly, I don't want to do that. Unless there's a nice, neat formula for that, but we should. I don't know. Oh, wait. There is a nice, neat formula. What is it? Oh, you're going to say it?
Isn't it just -1?
Which one did they minus?
The 1, 2.
The set with all the elements, right? Okay. So we've got our formulas now, and we didn't even know them, and it wasn't even in the book. The formulas are what?
2 and 2 and
Number of subsets is, and number of propers is 2 and -1, not 2 to the n -1, just a safety. So now, 2 to the 9th, right? What's 2 to the 9th? That's awful. 2 times 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 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 4, 4. You did it already? Did you do it in a calculator? 16. What's 16 times 16? Someone did that game. Remember that game we used to play on your phone? You know exactly what I'm talking about? It's actually really good for math because here, look at us needing it. Is it? 256 times 2 is 512. Is that what you got? Dope. And the number of this is the number of subsets. And what was the number of propers? Just get rid of the set with all of the elements. So the number of propers is 511. We probably won't have one of those. At the very least, you'll have like 6 sets, and it'll say, hey, what's a subset, what's not, is what I would expect, not this problem.
There's 18 subsets.
What?
Didn't we say 2 to the
Oh, were you talking about for the 4 one? 2 to the 4th is 16. Thank you. I was thinking too. I was like, make sure 4 times 4 is 16. Yeah. Cool. That's fun. That was exciting. Scary. Scary to have to. You're lost?
Yes.
Okay. Well, here you go. Don't be lost. Don't think about anything else. This is all you need to know right here. Where? What is in? I promise you. I will go buy a VGA to HDMI connector. I know I'm reconnecting because it's frozen. This is how to unfreeze. From the 7.
Wait, you said on the
Boom.
on the test you would just ask.
It'd probably just have you 6 sets, and it says which ones are subsets of the others, and you have to pick like 2, 3 is a subset of 2, 3, 4, that kind of thing. More like here, I'll show you an example. More like this one. It will, yes, more like this. But maybe a little bit like where you have some more of them that are like X, Y. Is that a subset of that? Yeah. Is that a subset of that? No. That kind of thing. Like very cleared out enumerated things. But this isn't bad either. Once we get down to this right here, the only thing you need to get to in your brain is what is in defined as.
Yeah, I can do that. But when you write everything out and
All the subsets.
yeah, that's where I just
Okay, well, what is in defined as here to make sure that we know exactly what this formula is saying?
N is the number of elements.
Yep. In a set. And this, as a side note, includes and, which has a name that I should have said earlier. Yeah, the set with all the things has a name. It's the opposite of the empty set, which is called. This is important. This is more important than knowing how to do it. The name of this? No. Yeah. Right? So it includes the empty set and you. And this includes what? It still includes the empty set, but it does not include. It does not include the universal set. That's the only, and that universal set is namely the one that was subtracted by the definition of proper. Proper means get rid of the main one or get rid of the full one. Include you in red, and this -1 is by definition subtracting you, the universe, from it. Saying if it's a proper subset, does not include the subset that is itself. Yep. Absolutely.
Can you explain again so I can understand it?
Yeah. Just this box, you mean?
No.
The whole thing?
Yes.
Okay. How many subsets does A have?
How can we get to the box? It's not a 7.
Because the 7 is the number of propers.
Is it 1, 2,
3 is the number of propers. Propers. 1 is the number of propers. Right? 30 was just bad. It should be 31, right? And that's the number of propers. And if you add the total set to it, that's the number of subsets. So these are propers. And we could, whoops, that was bad. And we could find the 4 one pretty darn fast. What would the 4 one be? 16?
15 for proper.
15 for propers. Good call. If I'm going to do it in the same bubble. 15 for proper subset. And then if you add the set of 1, 2, 3, 4, which is you, you're going to end up with 16 over here, which is your subsets. If you're like, nah, this sucks, I don't like it, make up a set with any 5 elements and just try to list them all out. Which is what I did here, poorly, when I added bad. But what I did here, to be really careful with it, was I said, hey, I want to think of all the sets with 1 element. What? Yes, I do too. I do too. So I'm going to go home and fix mine as well and then submit them. I was like, hey, I want to count all the 1 element sets, count them up. 2 element sets, count them up, and do it in an organized fashion. This is probably how if you did it already at home, you probably tried to organize it in some way that made it like easy to count. Like do all the 1s, then all the 2s, then all the 3s. and then there were only four element sets. You know what I meant. It's right there. There were 5 4-element sets where one was missing. And then if you're going to be full subset and not proper subset, we'd have to include the one universe, which is up there, which is R. Okay. Back to it. We can do another one. Or maybe 2. Now we can probably get one more in. All right. What else we got?
Should we just go over what equal and equivalent mean again?
Sure thing. Let's write it down here. Make up 2 sets. A, B, C. Make up second set. Circle, square, triangle. These 2 sets are A and B. A is equivalent to B. Any fun little math that I could do with A, whether it's counting subsets or counting sets or proper subsets or all the random crap we just did, the number would be the same for B. It would have to be. You just go in and replace, right? So that's kind of what that equivalent is helpful for, is saying, oh, any little math I could do counts for both. I don't have to do the math twice. But if they're exactly the same, now let's call C BAC. A is equal to C. It's also equivalent.
So equivalent means they have the same number of elements.
Indeed. And equal means they have the exact same elements only. But not subset. Not proper subset. Not they have the exact same elements and some less. They still have to have the same number. So they still have, equal means they have to be equivalent and be identical. Not just have the same elements. That's a subset. They do not have to be in the same order. Order doesn't matter in sets. Think of them as those blobs or the circles or whatever. That's more what we're looking at, even though they list them in orders. Arrays, which we won't do, but when you're doing sets in order, usually called an array, like ARRAY. All right. If you need, or if you want to work more of them, work on them together. Send me an email. Come to office hour tomorrow all day, Monday all day. Over the weekend, feel free to send an email and say like, hey, I need help with this thing. I'm happy to either just write it and do it, or Zoom, or work it out together, whatever you want to do. Come Tuesday ready to do your best.